Well, I'm going to use something called the arithmetic mean geometric mean inequality. This is something which maybe you haven't learned in school, but I think is such a useful tool for these sorts of questions. But what does the AMGM inequality say? Well, it says that if you have, I'm going to use a special case of it, but if you have x and y positive numbers, then x plus y over 2 is bigger than or equal to the square root of xy. So I'm going to get a half, which equals 16 to the alpha squared plus beta, plus 16 to the beta squared plus alpha over 2. Now, according to the AMGM inequality, this is at least the square root of 16 to the alpha squared plus beta times 16 to the alpha, beta squared plus alpha, like so. But now, just using kind of rules, this is the same as 16 to the alpha squared plus alpha plus beta squared plus beta, and I can write 16 as 4 squared, and so this is going to be 4 to this power. Now I'm just going to complete the square on this. It's going to be alpha plus a half squared plus beta plus a half squared minus a quarter, so minus a half, like so. So I've got 4 to this power is less than or equal to a half. Actually, this shouldn't, well, we should notice something here, because 4 to the power of, well, this thing here is always at least 0, because it's the sum of two square numbers. And then I'm subtracting a half, so all in all, the power of 4 is at least negative a half. But 4 to the minus a half is just 1/2. And so we've got that this expression here is both less than or equal to a half, but it's also bigger than or equal to a half. And thus the only value it can take is a half, and that's precisely when the sum of these two squares here is 0, and that's when alpha is minus a half and beta is minus a half. And that's the solution we'd already found. And therefore, the number of solutions to this equation here is 1.